All right, everybody. Um, Welcome to the first video that I'll be going to create for the data structures and algorithm, which is pertains to the basics only. Now, in this discussion, we'll be going to run through what is data structure. When we say data structure, that is a programmatic way of organizing and managing data efficiently so that it can be used efficiently and it can be accessed and modified easily. So when we say data structures, it will enable and enhance the performance of algorithms by minimizing both time and space complexity. So in data structures, actually, that refers to a method of we are organizing or we are storing or we're managing the data in a way that it will makes it easy to access and modify if necessary, since there will be a certain operations that we are trying to deal in terms of data structures. And in terms of that is also dealing with how efficient is that efficiency. So dealing with that, that emphasizes that our data structures really help in managing the data efficiently. So which is the crucial task for improving the performance of our algorithms. So anyway, let's move on. Data efficiency that is essential for applications that involve large data set, such as databases, web application, and scientific computing. And choosing the right data structures ensures data ensures efficient processing of data. So when it comes to data structures class, we are dealing with that is data efficient, since of course if you are dealing with choosing the specific right data structures for processing the data in such application. For example, if you are using array, then you wanted to access the specific locations of that data. So it is efficient because you can access that through the specific index. Where is it being stored, and you can access that right away. That's how it is. That's how it works. Now for optimization, that is also one of the importance of data structures, which is optimize the performance of algorithms. For example, searching a sorted list using a binary search algorithm is faster than searching a linear search. Both require the use of different data structures. Yes, of course, since in binary search, we are dividing that. For example, you have five array. Now, you will be going to divide that into two. So, of course, if this is your key element, once you will divide that into two, you will be going to, this is the zero and this is the high element. Once you will be going to divide that into two, this will be the middle element. So, you will only have one step that you can search this key element. Then the linear search, this is a brute force manner. So you cannot search this one here once you will not be going to search the first element. So that is a step-by-step process. Now, there will be a categories of data structures, which is the linear data structures. In linear data structures, elements are arranged in a sequential order. When we say sequential order, that is arranged in one step to each other. That's how it works. It is arranged one next to each other. Excuse me. Each element has a unique predecessor and successor, except for the first and last element. Of course, for example, this is 1 and this is 2, this is 3. So 2 is having a predecessor and a successor of 1 and 3. So 1 don't have any predecessor and 3 don't have any successor. Examples for this is array. So this is array. Linked list, when we say linked list, that is having a node connect to another node. That is how it works with linked list. Stacks is different. Stacks, we can access that through the top element because that is one-ended. And for queues, we can access both ended, but for the operation, there will be a specific um, unique way how to access those specific task. Now, nonlinear data structures. In nonlinear data structures, elements are arranged in an hierarchical. When we say hierarchical, there is a hierarchy. So in our tree, that is hierarchy. For example, this is level 0, level 1. So this is the CEO, for example. Then this is the managers and up until the employees. Interconnected manner. When we say interconnected manner in our graph, that is interconnected. So this is the graph. So graph A, graph B, and graph C is connected to each other. They do have specific relationship with each other rather than in a sequential order. So examples for that is a trees and graph as what I've stated. Now, for the characteristic of data structure, it must be correct. Data structure should be implemented its interface correctly and provide the expected behavior for operations like those insertions, deletions, and other operations and lookups. Because in data structures, it must really behave for how it should work. Data structures are defined by their characteristics and understanding. This is really essential when choosing the correct structures for a problem. Now, the time complexity, this refers to the efficiency um, of operations. A well-chosen data structures minimizes the time that it takes to perform tasks like accessing, inserting, or deleting the data. For example, searching in an array is a linear search, is a linear time. That is lower than searching in a binary search, which is a logarithmic time. Now, that is certainly right because if we are dealing in our array, if we are dealing with linear time, that is a linear search. When we are dealing with binary search, that is logarithmic. When we say linear time, one next to each other, we are searching that linearly. Logarithmic is how we search the binary search. That is how that is what time complexity dealing with. That is defining by their characteristic, and understanding that is really essential as well because we also know how the time really or what will be the what we call that one, how or what time is the behavior of that specific data structure? Is it that long, or is it best case or worst case, and so on and so forth? Now let's proceed with the space complexity. So space complexity refers to the amount of memory that used by the data structures. Some data use more memory to improve efficiency, while other are designed to use less. So, of course, in data structures, once you are dealing with linear search, for example, you're searching this one. So, once you will search this right now in a linear search manner, you are using a specific space. You're using specific space. You're using specific space. That's why the space complexity is not being reduced. So we are trying to reduce the space complexity. So if you are trying to use binary search, so it might also happen that we are also dealing with minimizing the space of that. Now, excuse me. Why study data structures? Efficiency in real-world application. Data structures provide efficient solutions to common tasks such as searching, sorting, and storing data. For example, a hash tables offer constant time access, which is the linear time for lookups, while an array offers linear for searching if that is dealing with linear time. Now, pertains to their hashing. That is, for example, we have um 10, 20. Say for example. Now, our operations for that hashing, we'll use hashing, we'll insert that in hash table. So for example, 2 is our container for the hashing. Now how can we do it? 10 divided by 2, it will become pila, it will become 5. So we only have um 2 container. So what we will do, so the 5, and then what will be the remainder? 0. So since 0 is the remainder, we will insert this in the remainder. So 10 is being inserted. Now for 20 as well, 20 divided by 2 is still 10, and there's no remainder, so it is still 0. So since that is a data collision, we can do a linear probing, so we can insert that in the next level. So that's how you will deal with um, hashing. But for searching that, it will still perform the same functions. 20 divide 2 is 10, then remainder is 0, search 0, 0 is not 20, linear probe. Is this one index? Is it 20? Yes, of course. You can access that real time. Now, studying data structures, understanding data structures allows you to also um, select the right one for the task, leading to better algorithm performance. For instance, choosing a queue for scheduling problem makes the process much more efficient than using an array. So this is really fundamental to computer science class, since you will know how to um, excuse me, optimize, organize, and store data in ways that makes the algorithm more efficient. So by understanding those properties, those advantages, and those limitations of different data structures, you can actually choose the best one for you for your task, leading to better performing system. And here then, we have the operations for data structures, which are the traversal, visiting each element in a data structure that is traversal. When we say traversal, we are traversing that. For example, we have 1, 2, 3, 4, 5. So we are traversing that. We are just printing that from first index up until the last index. We are trying to print that out um in our what we call this one, in our console, for example, excuse me. So we are trying to access every element. So in a linked list, we can traverse from the head node to the last node to display all the levels, all the values, I mean. So that's how it works in traversal. Each data structures support a set of basic operation, and that operation actually vary depending on the type of data structure. So right now here, we also do have insertion, which is we are adding a new element at a specified location. Example for that in a stack is we are also we can insert element at the top, since in our stack operation, I mean in our stack, we can only access at the top level. So therefore we cannot afford to uh, we cannot afford to what we call this one, we cannot afford to access the bottom part for that one. Now, for deletion, that is removing an element from a specified position, deleting a node from the front of a queue or a linked list. Since in a queue, you can actually insert that at the tail, then delete that at the front. So, of course, once you will begin to delete that right now here, you can easily delete that. In your stack, you can easily delete at the top element. Now, unlike that, if we are using array, you can delete anywhere. Here then, we're having a searching, finding an element based on a given condition or value. Example, linear search in an array or binary search in a sorted array. So we'll be going to picture out how to also deal with linear search and binary search later on. And update, modifying an existing element. We're just updating or we're just changing the specific element in value in an array or linked list. And memory, a real world application of data structures, memory management. Data structures like linked lists are more efficient than arrays in scenarios where the size of the data is unknown or fluctuating. So, memory management class, uh, it is memory efficient because we are storing in our memory in a sequential manner as well. So, for example, in an array, if you have 1, 2, 3, 4, 5, you are actually having a specific memory which we will be going to allocate that specific value. We will be going to picture out that in the latter part in our array topic as well. Now, real world application of data structures, we can apply that in a database as well. Applying in a binary trees and hash tables are used extensively um, to in databases to index and quickly retrieve large amount of data. Of course, that is right. Since in databases, we're dealing with it could be binary trees and that is level by level. And for hashing, that is a quick lookups, as what we have stated earlier. Networking. Graphs are used to represent networks and help in finding the shortest path in routing algorithm. So that is dealing in a graph algorithm that we are trying to check what will be the shortest path. What will be the shortest path if this will be our goal? So we will pass by here and this here. For example, is this the short path? This short path. So that is we are having two step. What about here? That is one step. What about here then? We have 1, 2, 3, so that is the shortest path is here. So that's actually dealing with the shortest path algorithm, and we will picture out that in your midterm term. And operating system, stacks are used in function calls and queues are used for task scheduling. So here we are having this, excuse me, in operating system, we are using different data structures. In your operating system courses in the future with Sir Gamboa or any course lead, you will deal with data structures still then. But of course, they will not be going to run through with that step by step because we are having that already in our course. Now, the foundations that we need to put into consideration for data structures, the interface and the implementation. For interface, that represent the set of operations that a data structure support or can perform, that specify what operations are available but not how they are implemented. Also called an abstract data type. So the interface class, you are actually trying to deal with what are those things that you are if it will be implemented through stack, if it will be implemented through queues, and what will be the operation that you will be going to deal with. So you are trying to check what will be the specific or suitable data structures um, in your system that you're trying to deal with. Next will be the implementation. You will provide the internal representation and defines the algorithm for performing the operation, and that refers the actual code that implements the data structures and its operation. So, what are those data structures and operations that you were able to deal with in the in um in the first hand earlier in your interface, it will be implemented here in the implementation stage. So that's how it works actually. So um please take note that this is really important in studying data structures because, of course, this is really necessary for you as well. So thank you so much for that class. Hopefully that you really understand everything, and we will be going to run through with everything in the future for the algorithms as well. So we'll be going to cut here and I'll be going to send that video separately. Thank you so much, everybody. And if you do have question, please specify in the comment section. And please also affirm your comment that signifies that you understand the specific lesson. Thank you so much.